Hi, today I will present the potential project called Continuous Intelligent Pandemic Monitoring. I hope this is a catchy title. If you have better ideas, please tell me. Okay, firstly, we'll talk about the specific research questions of this project. Before we talk about the questions, let's look at something about the background. We know that with the outbreak of coronavirus, authorities desperately try to find out accurate and timely information to control the transmission of the virus and provide sufficient instructions to citizens. However, I have to say that the numbers we currently have are all junk because of tremendous filtering on who get tests, lacking sufficient test kits in some areas, and some people may die at home and no one know about that. Based on this background, there are two research questions raised. The first research question is that, can we design a methodology or framework to improve the information quality and timeliness? The second research question is that, can this framework provide appropriate recommendations for policy implementations in specific contexts? Based on these two research questions, this research actually used a wide range of exogenous variables and attempt to apply continuous monitoring framework as well as AI algorithms in this coronavirus context. Then we'll talk about the potential contributions of this project. In other words, we will try to see why these two research questions are important. Firstly, this study actually tried to establish a continuous monitoring system for coronavirus. It will use a wide range of exogenous variables to perform comprehensive data analytics. This actually can improve the information quality and timeliness. Secondly, this framework actually provides the authorities a very detailed view of the pandemic, from the transmission of the disease to the required optimal level of intervention. We all know that there is actually a trade-off between the economy and social distancing, so we would like to recommend the best optimal level for the authorities. Finally, this system will provide a comprehensive set of recommendations on relevant issues. The third potential contribution is that, apart from predictions from classic academic models, this study will also use the AI models like neural networks to perform the multidimensional time series predictive analysis by using exogenous variables. After talking about the specific research questions and the potential contributions, I would like to discuss the methodology, how we can resolve the research questions. In this part, firstly, talking about the continuous monitoring framework applied in the coronavirus context. There are basically 4 steps because I have presented this framework before, so I will make it more briefly. The first step is that we'll try to establish a timely updated data set. In this data set, there are basically 2 kinds of data. The most important data we use is the exogenous data, which is collected from the internet and some other channels. It will include personal GPS data, Google Flu Trend, favorite data based on the thermometer reading apps, and so on. The second step is based on the data collected in the first step. We'll try to establish a series of models. For example, we'll try to use the AI models, the classic epidemic models to predict the infected cases, fatalities, and inflection points during the disease outbreak. Apart from that, we also try to identify the potential correlations between confirmed cases, fatalities, and a series of economic indicators, such as unemployment insurance claims. There is a new idea we come up with this weekend. Actually, we try to explore some specific features of contaminated patients. For example, their age group, whether they are suffering from other non-related disease, whether they commute to work every day. We would like to use these features to create a score system to gauge infectious risk for target population. We suppose that can be helpful for authorities. Then the third step is a lot system. Based on the predictions from the second step, we'll try to assess the risk, and the alert will be generated if the predicted value reaches the threshold, which means that significantly risky consequence will happen in the future. The final step is actually a recommendation system, which is one of the most important elements in this system. We assume that if the alert is triggered, certain preventive policies and strategies should be automatically recommended. Note that with the help of a set of simulations, we hope that we can identify the optimal current policy when confronted with the trade-off between social interventions and the resulting negative impacts on the economy. This is a basic framework of our project. Then we'll talk about the specific approach incorporated in the framework. Basically, there are three specific approaches incorporated in the framework we talked about. Firstly, the first type of approach is classic epidemic models. Actually, we would like to use this series of epidemic models to predict the confirmed cases, the fatalities, and the inflection points in different US states. Additionally, we can actually simulate the effects of public health interventions like the social distancing and lockdown on coronavirus transmission. We suggest that this kind of simulations can provide better guidance on the social distancing policy. For example, in the figure 2, we use this SIR model, which is a very basic epidemic model to fit US confirmed cases. Actually, this model is not very reasonable, and we can say that in the predicted inflection point is around 89 days after the outbreak. However, perhaps due to the insufficiency of tests, right now we cannot see the inflection point of the confirmed cases in the US. Perhaps we should use a more sophisticated model to fit the curve. In the figure 4, we simulate the impacts of different social distancing policies on infected case, assuming the total number of population is equal to 1,000. This kind of simulations can be widely used to help us to make better decisions. Well, the second type of approach is a series of AI predictions. We have to use a wide range of machine learning algorithms like SVM, XGBoosting, RN, and LTSM to help us to predict the fatalities, confirmed cases, inflection points in the US states. These models will be trained on the source case dataset or coronavirus 19 in Wuhan case dataset. Why we train the model on these two datasets? The reason is that we hope to accurately predict the inflection point in the US. So using this dataset can really help us in doing this. Note that in order to more accurately gauge the target variables, we try to use several time series exogenous variables, which include Google flu trend, medicine purchase trend, and some other time series variables. The third specific approach applied in the framework is correlations, because we try to identify the correlations between a series of like the infected cases and economic indicators. So this approach is very important. The basic idea is that we can use the currently accessible data in the US or China to find out the association between the economy indicators and confirmed cases. Then we can infer this relationship in the future to predict the changing of economy indicators. This is a basic idea of this project. I hope this is not a conceptual paper, and in the future we'll do it in a more from the perspective of data analytics. That's all. Thank you.
I think this is very good, Hanshin. I have one little question to you. Can you just talk for a second about that index that you recently developed? What are you thinking of doing there?
You mean the Italian text according to specific features? You mean this sentence?
Yes.
Okay. What we are thinking is that we can find out some commonalities among the contaminated patients, like their age, whether they are suffering from other non-related disease, their migration information, whether they are going to the European, whether they are going to China, whether they commuting to work by taking the metro every day. This information can actually help us to create a profile of the patients, and we can use this profile to create a score system. For example, we can predict the probability of infections for specific people. Perhaps that can help the authorities to gauge the risk for the target population.
So this is a multidimensional suspicion index that you're trying to do, focusing on contaminated people identified as contaminated. Is that correct?
Yes, and what we are thinking is also that perhaps we can use some unsupervised learning methods like the autoencoder to help us to reduce the dimensions just into 2 dimensions, and we can visualize the boundary of the infected, uninfected. Perhaps it's a very useful visualization tool.
Yeah. Well, meaning the one problem here is that there are many contaminated people that are non-symptomatic, so you don't know they are contaminated. So your index will be biased towards people with strong symptoms, meaning people with detectable symptoms. I wonder if you could improve this by maybe tying it up to something like the formal study, which got 2,000 random tests from people in supermarkets. And that would give you a better index, I think.
Yes, I suppose this would be better.
Hi, Hanxin. Thank you for the presentation. I just want to ask, from your model, so what's your prediction for the turning point of this pandemic?
As you can see in the figure 2, the inflection point is 89 days after the outbreak. Actually, this is 96 days after the outbreak, but we cannot see the inflection point of the confirmed cases. So I can only say that this is due to the insufficient test in the US.
So the dots are the actual confirmed cases, or yes. I'm just trying to count. Okay, that's the actual, and the purple line is the
predicted.
The predicted. Okay, so day 0 starts from which day?
It starts from the January 22.
Oh, so that's about
January 22. Yes.
I'm just thinking that maybe in your project you can briefly discuss what's your prediction versus what's the government's prediction, and what are the predictions from other agencies. And I'm just wondering, have you looked at the models cited by the White House? Because every day they do this briefing, and maybe you can compare what's the advantage of your model compared to their model, right? And just it's to show that you have this advantage, right? For example, you can talk about the type of data you use, and other aspects that have been taken into consideration. But I think that in general, this is great. Yeah.
Thank you. And just considering that if I try to predict the inflection point of these cases, perhaps the results will be more reasonable compared with the prediction of confirmed cases, because the confirmed cases really have so much noise in the data.
Yeah.